Welcome to Cyberoam Online CCNSP Training Module 11. In this module, we'll be learning general administration. So this is the agenda of our presentation. We'll be learning about access management, DNS and DHCP management. We'll also learn about Cyberoam OS management and backing it up and restoring it as well. So let's have a look how to configure the web admin settings. Now, if you want to change the port number of your Cyberoam GUI, you can go to Sys Administration, you can go to Settings, and then Web Admin Settings, and here you can change the HTTP and the HTTPS port number. So the default is 80 and 443. Now, if you'd like to change it to a custom port number in case you might be running a web server inside or any other server which is running on the standard port numbers, you can come here to this particular place and change the port numbers over here. You can alternately also import a third-party certificate to access Cyberoam instead of using the generic or default appliance certificate. Now let's have a look at the different login security mechanisms for accessing Cyberoam. So to prevent the unauthorized access to the web admin console and CLI, you can configure admin session lock. You can configure admin session logout time and block admin login to block the access after a number of failed login attempts. You can also configure inactive time for web admin console, telnet console, IPsec connection wizard, network wizard, and also on the group import wizard as well. So you can see you've got some settings for login security. You can say that log admin session after 3 minutes of inactivity, or you can change that to a certain amount of time. You can also log out the admin session after certain minutes of inactivity, and you can also block the admin login. Now, if you want to have access control on the appliance, you can go to System, you can go to Administration, and you can go to Appliance Access. It allows or limit your administrative access from LAN, WAN, DMZ, and VPN for admin services. So if you uncheck any one of this, for instance, so if you uncheck this telnet option from the LAN, you'll not be able to telnet to Cyberoam from LAN side. If you uncheck the HTTP option from WAN, you won't be able to access the Cyberoam GUI from WAN side via HTTP. The same thing goes with authentication services as well. If you uncheck this Windows client, for instance, from the LAN, you won't be able to log in via the Windows client or the Linux client software, which we demonstrated in authentication module. Same goes with the login page, which is captive portal as well, and for NTLM. Now for DNS and ping, it's the same thing. If you uncheck ping from any specified zone, you'll not be able to ping to that particular interface. The same thing goes in VPN as well. If you uncheck this option, you'll not be able to ping across VPN. And the same thing goes with DNS as well. And other services like web proxy and SSL VPN. Role-based administration. Cyberoam offers you role-based administration. So what is role-based administration? Role-based administration capabilities are provided to offer greater granular access control and flexibility. It allows an organization to separate super administrators' capabilities and assign through profiles. The profile separates features into access control categories where you can enable none, read-only, or read-write access. This can be very helpful in an organization where you've got like multiple administrators and you've given them different roles for different administrators. Let's say, for example, someone will come on configure only VPN settings because he's an SME on VPN and he's a VPN subject matter expert. So you create a role-based administration control and you give him VPN read-write configuration access to Cyberoam. So for ease of use by default, Cyberoam offers you 5 profiles, which is the administrator, which is the super administrator with full privileges. He can go ahead and create different administrators. He can go ahead and create different profiles for different administrators as well. The next profile is the security admin, which has got read-write privileges for all profiles except log and reports. The next one is the audit admin, which has got read-write privileges for logs and reports only. So if the audit admin If you assign this profile to a particular administrator, he can log into Cyberoam and can only check logs and reports. The other one is the crypto admin, which has got read-write privileges for certificate configuration only. And the last one is the HA profile, which has got read-only privileges for HA configuration. Now, the appliance is shipped with superadmin having username and password as admin. And both the consoles, the web admin console and the CLI, can be accessed with the same credentials. This administrator is always authenticated locally. So in order to change the password, you have to go to System, to go to Administration and Password, and then here you can change the password. It's always advisable to change the default password and we show a warning message or alert in the dashboard to change the password for the admin. If you click on that hyperlink in the dashboard, you're automatically redirected to the same page. However, do not forget to change the password of admin. Let's have a look at DNS management of Cyberoam. Now, Cyberoam OS allows you to configure up to 3 DNS servers. Cyberoam can be configured to get the DNS from upstream DHCP server, DHCP from PPPoE, or DNS can even be static. You can go to network, you can go to DNS, and there you can configure IPv4 DNS or IPv6. In the screenshot, we have configured static DNS as you can see, and we've configured the global DNS. However, if your ISP is offering you DNS from DHCP, you can select that option, obtain DNS from DHCP, or if you're using a PPPoE connection, you can even select this option as well. Now there are certain DNS query configuration at the bottom, which you can see choose server based on incoming request and record types. You can also choose IPv6 DNS server over IPv4, or vice versa, choose IPv4 DNS server over IPv6. And you can also choose IPv6 if request originator address is IPv6, or else you can go with IPv4. And the best thing is you can do a test name lookup to see whether your DNS resolution is happening properly from Cyberoam or not. You can also alternately add DNS host entry in Cyberoam. DNS host entry allows adding DNS mapping of domain or host name with IP address. So if you add a static entry, it allows you to resolve some host or domain using Cyberoam. In order to configure DNS host entry, you need to go to network, and then you need to go to DNS and DNS host entry, and you click on the add button over here, and you can publish it on the WAN as well if you want to configure it, and you can also do a reverse DNS lookup as well if you want to do that. You can also configure dynamic DNS on Cyberoam. Now Cyberoam itself can be used as a dynamic DNS. In such case, Cyberoam will be responding to all DNS queries for the published hostname RFQDN. Now you can publish the port IP if public IP is terminated on Cyberoam. So you can use this option if there is a public IP terminated on Cyberoam. If your Cyberoam has got a private IP on the WAN, you can select this option, NATed IP. The default interval at which Cyberoam will check for IP changes is 20 minutes. Now there's a small note at the bottom which is very important. Host name must end with star.ddns.cyberoam.com. And an example would be, which you have taken in the screenshot, is ccnsp.ddns.cyberoam.com. So if you are planning to use Cyberoam as your DNS provider, you have to use whatever XYZ or whatever .dns.cyberoam.com. So you have to use that. So keep that in mind if you want to use Cyberoam as DNS service provider. You can also configure other DNS service provider like DNS or ZoneEdit, EasyDNS or DynaAccess, or else you can select it to be Cyberoam. The default TTL for published records is 1 minute when Cyberoam is selected as provider. Now let's have a look at the DHCP management of Cyberoam. So in order to configure DHCP, you need to go to Network, DHCP, and Server. Now remember, each LAN and DMZ port on Cyberoam Layer 8 Firewall can be configured to act as a DHCP server. And using CLI command, Cyberoam DHCP server can be configured for IPsec site-to-site VPN to lease out IP addresses to remote branches. You can alternately also configure a static IP lease on Cyberoam. So this is how you configure DHCP on Cyberoam. Here you have to select the interface for which you'd like to lease out IP addresses. You can configure dynamic lease and a static lease as well. So here you can see that you've got a start and end IP from 1 to 2 till 1 to 10, and the second scope is from 13 to 30. So you can have multiple scopes, and here you've got like 11 and 12 for these two IP addresses. We have kept a reserved scope or a static DHCP lease. When you want to configure a static DHCP lease, you have to take the MAC addresses and map it to the IP address for which you want to lease out the IP addresses. And here you can select the interface as the gateway, and there are some default DHCP settings for lease time. You can also configure DNS IP addresses for those IP addresses which are leased, and you can also configure Win server via DHCP as well. DHCP relay agent. What is a DHCP relay agent? The DHCP relay agent allows to place DHCP clients and DHCP servers on different networks. A very good example would be, let's say you are using Microsoft SBS server as a DHCP server, and you've kept that server in the DMZ, and you want your LAN users to get DHCP from the SBS server which is on the DMZ. Now DHCP requests and responses, since they are broadcast messages, are normally dropped by a layer 3 router. And that is when you need to have the layer 3 device to act as a DHCP relay agent. And that is what is done by Cyberoam as well. So multiple DHCP servers can be added in DHCP relay in Cyberoam. The DHCP relay agent makes it possible for DHCP broadcast messages to be sent over routers that do not support forwarding of these types of messages. Now there's a small note which is very important. DHCP server cannot be configured when Cyberoam is deployed in bridge mode. And you've got the DHCP relay configuration over here. You select the interface, select the IP address of the DHCP server, and in case you'd like to pass on DHCP request and response through VPN to your remote sites, you can enable relay through IPsec. Now let's have a look at the Cyberoam OS management. So you can go to System, you can go to Maintenance, and then you go to the firmware option, and this page displays the list of available Cyberoam OS versions which are downloaded onto your appliance. Now at a time, maximum 2 Cyberoam OS versions are available simultaneously, and one of the 2 Cyberoam OS versions is active. So the firmware which is deployed. So in this particular screenshot you can see there are 2 firmwares, but this 10.6.1 RC1 is the one which is active on Cyberoam currently, and it is the one which is deployed in Cyberoam. Now how does Cyberoam do the OS versioning? It's very important to understand when you release a firmware, what exactly that release contain. Now there is a suffix feature which we'll be explaining it now. You can see here 10.6.0 beta 2 and 10.6.1 RC1. So this 10, what is this 10? 10 means it's an architectural release. If this version changes from 10 to 11 or some other number, which means we have changed our architecture. As long as it's 10, you know, okay, it's on the current architecture and there is no change in this particular release for the architecture. The next octet, which is 06 or whatever, it can be 07 or 08, that is a major or a feature release. So on the next release, if this number changes to 06 or 08 or 07, you understand, okay, there is a lot of new features coming in and it's a major release. And then you've got now the suffix, which is the minor or enhancement release. And finally, there is another one which is MR, which is the maintenance release, which is just for resolution of certain bugs and all that, and it's a fix. So that's the maintenance release. So this is how the Cyberoam OS versioning is done. Let's have a look at the configuration migration and how 2 operating systems are managed in Cyberoam. So you've got CL Loader, which is responsible for maintaining the operating systems and loading the operating Cyberoam OS into your appliance. Now you can see the first Cyberoam OS is Cyberoam OS 1, which is currently the active firmware on the appliance, and you've got configuration 1 related to Cyberoam OS 1. Now you might have uploaded a newer version of Cyberoam OS. So you uploaded the newer version, which is Cyberoam OS 2. Automatically, the configuration is migrated from 1 to configuration 2 related to OS version 2. And this configuration is migration is one time only. And the other thing noteworthy which you need to keep in mind is the CL loader, Cyberoam operating system and configuration. All of this stays on the flash of each and every appliance. The signature and the report stay on the hard drive, as you can see it on the over here. So this is very important to understand the architecture of our Cyberoam configuration migration. So let's have a look at how Cyberoam is upgraded in high availability. Upgrading Cyberoam OS when appliances are deployed in high availability, there will be zero downtime. So this is very important. From this release onwards, there will be no downtime while you upgrade Cyberoam appliances in high availability. Now, how will the flow of the upgrade happen? The primary appliance gives the upgrade to the secondary appliance. Then the secondary appliance comes back up and takes control of the network. And then primary appliance upgrades and comes up, and HA becomes active. So that's why you receive zero downtime even if the appliances are in HA and upgraded. Now let's have a look in detail what exactly is a CR loader, which we saw in the earlier slide. CR loader or Cyberoam loader is a critical component to load Cyberoam operating system, and it also has some essential tools for troubleshooting and recovery of your operating system. It helps in loading new firmware, conducting memory tests, disk tests, Ethernet card tests, upgrading the loader, resetting the console password. It has got some nice diagnostic tools. All these tools and a lot of other tools are also provided in the Cyberoam loader, which is very important to check your hardware and all those stuff. A lot of troubleshooting tools is embedded in Cyberoam loader. So let's have a look on how to do backup and how to restore it back. So Cyberoam OS configuration can be backed up and restored as and when required. So if you want to take a manual backup, you can go to maintenance, backup and restore, click on backup now over here, and you can download the backup and keep it safely onto your laptop, desktop or a server. Now when the Cyberoam crashes or you probably want to restore back the backup, you choose the file, select the backup and click on upload and restore it. Now manual backup is good as long as you're maintaining or currently the daily or a weekly backup. However, we have given you an automated backup which is a scheduled backup. You can set the backup frequency to be daily, weekly or monthly, and you can request Cyberoam to send you an automated backup on an FTP server, email, or even save it on the local appliance as well. If you're selecting it as an email, mention the email address and you'll be automatically getting the backup emailed to you depending on the frequency which you set it over here. Now there are two very important notes at the bottom which is very important, and you have to keep that in mind every time you do a backup and restore. Backup of higher Cyberoam OS version cannot be restored to a lower version of Cyberoam operating system. However, the reverse is always true, or you can do that. So you can always take a backup from a lower version and restore it on a higher version, but you can't take a backup from a higher version and restore it on a lower version. And the same thing goes with note 2, which is backup of higher model cannot be restored to a lower model appliance. But you can take a lower model backup and always restore it on a higher model. So these two very important notes, you always keep it in mind while you do a backup restore in your live network. Now you can also participate in the product improvement program. So customer can choose to participate in product improvement program. You can go to maintenance, you can go to updates, and then over there hot fixes. So you can select allow over there hot fixes, or else you can also participate in the product improvement program. You can also do a manual signature update. You can download the signature file and you can upload it manually if you do not want Cyberoam to update its signatures automatically. This scenario can be very helpful in environments like defense, wherein the appliance doesn't have internet and they don't expose the appliance to internet. And that is when it's advisable you download the signatures manually and then you upload it onto your Cyberoam. So let's have a look at the different troubleshooting tools provided by Cyberoam. So the Cyberoam appliance comes with the bill of troubleshooting tools. You've got packet capture to capture different packets and see what's going on inside your Cyberoam. You've got TCP dump, which is a command line tool to capture packets. You've got ping. This option is available both from the CLI and from the GUI as well. You've got trace route, you've got name lookup, you've got route lookup to do check up for routes, and you've got a CTR, which is consolidated troubleshooting report, which you can download and submit it to support for checking what's happening with Cyberoam. So let's have a look at the packet capture tool. You've already seen this screenshot or seen this particular screen in one of the earlier modules where I was showing you through which rule your packet is going. So it's a very handy tool for troubleshooting. You can click on configure and you can configure for which IP address and port number you'd like to capture packets. So you get the in interface, you get the out interface, you get the ether type, the source and destination IP, and you can also get the packet type, whether it's an UDP or a TCP. You get the port numbers, which are the source and destination ports, and also the rule ID, which is very important so that you identify your packet is going via which rule. And this is very important as well, the status, whether it's a violation or not. So if it's a violation and you see the reason as well, so you know, okay, this is what's happening inside my Cyberoam. You also get to see the web category and a lot of other fields, which we'll be showing it in the lab as well. Now, then the status, the incoming will always have a rule ID of 0, since you can see the packet is incoming towards Cyberoam and it is not yet processed by any firewall rule, and hence it has got a rule ID 0 and it says incoming over here. However, if you get the forwarded packet with the rule ID 0, which means there is a problem because it is not yet processed by any rule. You can also have a look at the detailed header information over here. You can see the packet information here with the Ethernet header, IP header, and if you scroll down you can get the other headers as well. And this is the hex and ASCII details. If you're interested in that, you can have a look at that over here as well. Now let's have a look at the command line tool or utility, which is TCP dump. Now if you want to capture packets via CLI or command line, you need to fire this command TCP dump, and it shows you all the packets which are flowing through your Cyberoam at this point of time. Now before I move further and show you the meaning of the packets, what exactly is happening over here, I would like to take you to the whiteboard and explain you the different flags of TCP which participates in a three-way handshake. So let's go to the whiteboard and I'll show you and explain you the TCP three-way handshake. Now if I take two parameters, I'll draw it as requester and there is a responder. Now let's assume you are browsing google.com. So the first packet which goes, the TCP packet, is a SYN packet, and then the server responds back with a SYN acknowledgement saying that okay, I have received your SYN packet and I acknowledge that. Now finally the requester will send, okay, I've received your acknowledgement and I acknowledge that I've received your acknowledgement. So this particular phase is called the opening of a connection or a three-way handshake. So this is called the three-way handshake or opening of a connection, and then the push packets test starts in, which you can see in Cyberoam in the form of P format, and these are the data packets, which means that data is being transmitted and you get the web page displayed over there. Now when it's time to close the connection, so let's say you close the browser, so the requester sends a finish packet, which is a fin, and the responder sends, I've received your finish packet, which is fin represented with F, and it says with fin acknowledgement. So the responder or responder says, I've received your fin acknowledgement. And finally the requester says, okay, I received your fin acknowledgement and I acknowledge it. And this is called a three-way closure and the connection is terminated. However, apart from this fin packet, push packet, SYNAC, there is also another flag which is a reset. And let's say you requested a connection and the server responded back with a reset packet from here. So I'll probably change the color. And let's say instead of SYNAC, someone is sending a reset packet, which is R. So you understand, okay, the server port might not be open. That's why the responder is sending a reset packet. Now, if the destination server, well, you take a capture and you see the packets and you see the destination server is sending a reset packet, you understand, okay, the port is closed. Probably there could be some issue with the server itself. However, if you get the same reset packet from Cyberoam, you understand, okay, either there is no rule built on Cyberoam to forward the packet and that's why it's sending a reset packet, or else probably there is some issue with Cyberoam. So that's when you need to check Cyberoam. However, if the end server is sending a reset packet, you know, okay, there's a problem with the server. Alright, so now let's go to the presentation and let me explain you the fields. So here you can see that we have taken a TCP dump on port number 21, which means I'm trying to capture all packets on port number 21. So let's have a look what exactly happens over here. So here the requester or the private IP address is 10.120.16.100, which is requesting, and the destination server is 192.168.1.39 on port number 21. So it shows a new connection originated from 10.120.16.100 and destined for 192.168.1.39 to access FTP. This is the first packet, and as a result of which you see the SYN flag set, which is SYN flag, which I showed it to you in the diagram. Now the same packet is now natted with the public IP address the same packet is natted with the public IP address, which is 10.103.4.247, and it goes to the same destination as well. So this was your initial computer IP address. Now it's natted by Cyberoam with the public IP address, and it's going to the same destination, and it's the SYN flag as well. Now you get a response from the server. So here you can see you get a response from 192.168.1.39, and it goes to the public IP address, which is the SYN flag is set, and acknowledgement, which is the acknowledgement from the server, and it's saying that, okay, I've received your SYN packet. And in the next packet you see the same server is sending it to the end computer private IP address. So first it sends to the natted IP address, and then it goes to then Cyberoam forwards it to the private IP address, and as a result of which you see another packet coming from the same destination to the same source which you requested. Now, in order to complete the three-way handshake, the private IP address sends acknowledgement packet back to the destination. So you can see it over here, the private IP address 16.100 sends an acknowledgement packet, and it says, okay, it's an acknowledgement, and then the same is forwarded by the natted IP address to the destination, and this completes the three-way handshake. So you got SYN, you've got SYN-SYNAC, and then you've got an acknowledgement, and now it's time for the push packets to flow in. So what happens when push packets flows in, or where you see push packets over here? Yes, you're right, the data starts flowing in. So you're actually transmitting data now. Your connection is now opened, and you can see all the P flags over here, which means the data is started flowing. Now it's the termination of an FTP connection, wherein the server is sending a termination or a FIN packet to the public IP address, and the same thing is forwarded to the private IP address by Cyberoam, and it says, okay, the server says, I want to finish the connection, and you see the FIN packet set over here as well. Now in the next packet, you can see the private IP sends an acknowledgement packet to Cyberoam, which forwards it to the FTP server. So the private IP address over here, 16.100, sends a FIN acknowledgement to the destination, and you see the FIN and the acknowledgement packet. The same is being forwarded by the public IP address or the natted IP address to the destination. And after that, the private IP sends FIN packet to Cyberoam, which forwards it to FTP. And server sends an acknowledgement packet to Cyberoam, which it forwards to the private IP. So the server over here sends it to the natted IP first, the acknowledgement over here, which you can see, and then it's forwarded to the private IP address over here, the acknowledgement, and that's the end of the connection. So this is how a packet flows in a normal network. You have to keep the sequence in mind, the three-way handshake and the three-way closure, and be very careful of the NATed IP address. While you see the packets, you can understand if there is no packet with the public IP address, you understand, okay, the NATing is not happening in my network. So I need to take care of that. Maybe you haven't deployed the Cyberoam in NAT mode and you've deployed it in route mode. So you don't see the NATed packet, the second packet, you don't see it in your packet capture. So okay, I'm not doing any NATing. This is in route mode. It's fair enough, so you don't see the next packet. But if you are doing NATing and you have deployed Cyberoam in NATed mode and then you don't see the NATing being happening in the packets, then okay, it's a problem. I need to take a look at my configuration. So that's how you troubleshoot the packets via TCP dump and packet capture. Now there are certain TCP dump parameters which you need to keep in mind and which comes very handy for troubleshooting. So in your troubleshooting, you can say TCP dump host and then IP address for which packet you'd like to capture packets. And you can say TCP dump host 10.10.10.1. Maybe you can have for the source host as well a destination host, or you can capture packets for an entire network. You can also capture packets for a specific port number over here, or else you can do a mix and match and make the command more efficient by saying that okay, I just want to capture packets for this host and this port number because you're troubleshooting on that particular IP address. So you can make it more restrictive so that you get less packets and it helps you to identify, okay, what's going on. So you've got this as a document in our knowledge base as well. Maybe you can refer to the presentation or to our knowledge base article as well. Now there is also a command line utility as well as a GUI utility which we have given you is the ping. So in order to start the ping, you need to navigate to System, Diagnostics and Tools, and you can put in an IP address which you want to ping, select the interface and select the size as well, what size of packets you want to send it, and click on ping. And if you get a reply, okay, it's responding. If you don't, you'll be getting request timed out over here. We've also given you a GUI tool called traceroute. So if you want to start the traceroute tool, you need to navigate to System, Diagnostics and Tools. You can put in the IP address and via which interface you'd like to traceroute it, and you get the analytical data or the report over here of the traceroute. We have also a tool called name lookup. So you can go to System, Diagnostics and Tools, and you can do a name lookup for a particular domain via a particular DNS server. Maybe it can be a global one if you want, or else you can also do it via your own DNS server configured in Cyberoam to see whether the name resolution is happening properly or not. And if the lookup is successful, okay, with this DNS server the lookup is successful. However, probably you might have experienced that with your private DNS servers the lookup is not successful. And then you understand, okay, there's a problem with my private DNS server, the lookup is not happening. So this is a very nice troubleshooting tool which you get with Cyberoam. Similarly, you've got another tool which is called the route lookup. So if you want to check the route, where exactly is this IP address located, you can put in an IP address and click on route lookup, and it says 4222 is located on port C and it's reached through the router 10.120.16.1. Now we also give you the option to generate a CTR and download it. So what is CTR? It's a consolidated troubleshooting report. The CTR file is advanced level of troubleshooting and is meant mainly for Cyberoam technical support staff. So you can generate CTR, you can select this option with system snapshot and also the log files. You can put in a reason and generate it, then download it and submit it to the Cyberoam tech support team. Now to understand the CTR in detail is out of scope for CCNSP, and more about CTR is covered in CCNSE, which is the expert level course. We are not going to cover much about CTR in this particular course. However, we have talked about a lot of CTR in the next level. So let's do the labs. So we've got lab 25, 26 and 27. So the first lab which we'll be doing is a traffic analysis with packet capture. So let's start with the first lab, which will be using the GUI based tool. So let me just do RDP to my lab infrastructure and start the labs. So let me remote into my lab infrastructure. And in order to find the tool, I'll go to System, Diagnostics, and Packet Capture. What I'll try to do is I will enter a string. I'm trying to capture packets on port 80. So I'll click on OK and I'll click on Start. And let me browse some website, cyberoam.com. I'll refresh it. Alright, so cyberoam.com, this is the public IP address. So let me scroll down to the bottom. I'll just increase the number of records per page. So I've increased the number of records per page to 40. And let us scroll down. And here you can see, I'll show you the exact details what happens inside a packet capture. Now this is my lab PC 172.16.16.17, which is behind Cyberoam. And Cyberoam has got a public IP address of 10.206.1.113. So the first packet came to Cyberoam and it went to the website cyberoam.com on this public IP address, and this is via rule ID 0 since it's an incoming packet. Now then the packet went out being natted with the public IP address of Cyberoam, and it went out to rule ID 2 and it shows generated. So that's why you can see the clear natting over here. You can also see the packet went out via port B. However, if you see the first packet, it's an incoming packet on port A. Now let's have a close look on rule ID 2. Which rule is it taking? So I'll go to Firewall and I'll go to rule, and I see I'll go in via rule ID 2. Why is that? Because I am an authenticated user, and this rule says any live user or authenticated user, and hence I am taking rule ID 2. So let's go ahead to the next lab. So lab 26, which says backup and restore appliance. So let me remote into that, and here I'll go to system, I'll go to maintenance, and here I come down to backup and restore. Now there are three backup modes which you can use. You can either take a backup on the local appliance, you can send it to an FTP server, or else you can email it to a specific email address. You can also write any backup prefix like HO or BO for multiple appliances, so that if you are sending a particular backup to an FTP server or email, you can identify different appliances which backup you are receiving. And you can also set up a backup frequency to daily, weekly, or monthly. So I'll click on apply, and I will take a backup as well right away, and I'm taking it on the local appliance. So you can see I can download the backup. Once I download the backup, and whenever I want to come back and restore it, I'll click on choose file, and then I'll click on upload and restore, and the backup will be restored. So that brings us to the end of this lab. So let's proceed with the next lab. So let's get to lab 27, wherein we'll be customizing web admin console port. So let me remote into my lab infrastructure. So I'll go to system and I'll go to administration, and here I can customize the HTTP or HTTPS port number. Just for the sake of it, I'll customize it to 8080. I'll click on apply, and I will log out from Cyberoam. So see, even though I've logged out, it's just rotating around here, which means I have lost access to Cyberoam. So let me open a new tab, and let me browse to Cyberoam's IP address 172.16.16.16:8080. And see, I've got the access of Cyberoam on 8080. So I will change it back so that it helps me in other labs as well. So I'll click on apply, and that's it. So that brings us to the end of this lab. Let's continue with the presentation. So let's continue to the presentation, and that is the end of this presentation. And the next module which we'll be doing is logging and reporting, and that is the last module in our training. So thank you very much for attending this presentation.